I'm going to go on to section 2. I think it's probably a little early for our first break, so we'll probably have a break after we get through this section. And that is, we're talking about an overview of the assessment process. Basically, what are the scales of the assessment? How do you handle spatial and temporal variability? How do you use the method in created or modified streams, as well as disturbed or altered systems? For the most part, everything that I present here is consistent with what we discussed in the Arid West. So a lot of the same principles we talked about earlier apply here. The assessment reach length, it's based on 40 times the mean channel width. You can adjust this, but you can't go shorter than 40 meters, and you shouldn't go longer than 200 meters. If you do more than 200 meters, it's pretty impractical for the field crews. You introduce a lot of heterogeneity in terms of the flow duration within that reach, or at least you have the potential to do that. So that's why it's capped at 200. If you go below 40, you're just not giving yourself enough opportunity to observe the indicators that you need to. We limit the lateral extent of the assessment to the half channel width. So basically, you're only looking at things you observe in the channel or near the channel. And the reason why you do this is that, like, in this case, if you find some, aquatic invertebrates in that off-channel pond over there, that's not really informative about the stream flow duration in that river. So it's not really telling you anything all that meaningful. That's why we focus just on the channel and the half channel width from it. In multi-threaded systems, we want to look at the entire active channel when we estimate reach length. Some indicators can be observed in the primary low flow as well as in secondary channels. So you sometimes need to look at both, but it's not like you have to do independent assessments on each channel. As we know, there's a lot of spatial variability in how streamflow duration is expressed. A good illustration of that is the influence of valley confinement. So if you have a stream that goes from a canyon into a plain, you might see some of these indicators more readily in one situation than another. The drivers of streamflow duration change quite a bit over this difference. So you want to be aware of how this changes over say a project area to know when and where you're going to put your assessment reaches. There are many factors that can influence the variability in stream flow duration, and these will affect how you should measure or interpret your indicators. Things like changes in stream size, watershed area, or how much water is getting discharged. Changes in sediment loads that can certainly dictate how much water can percolate into your groundwater. Changes in land use for water management, the geological variability, channel modification, and sometimes water quality degradation can also affect indicators, particularly the aquatic invertebrates and algal cover. So when you're trying to figure out where to place your assessment reach, you want it to have relatively uniform channel morphology, and you really want to focus on the drivers of stream flow duration, things like the valley gradient or the width or the composition of the substrate. You don't want to look at the presence of surface water and trying to figure out where to place your reach. You do want to avoid including a major tributary or a sharp transition in some of these drivers within the assessment reach. It's better to have, one assessment above a transition and one assessment below. If your reach is influenced by a road crossing, that can really alter hydrology for a reach. If you have the opportunity and it's appropriate to do so, it's probably better to avoid that and give yourself like a 10-meter buffer from that road crossing. It's also okay to modify the reach placement or the reach length if you need to avoid trespassing on private property. This image just kind of illustrates how road crossing can alter flow locally. This map shows a few ephemeral reaches that go under a highway, but right around the highway you see much more vigorous growth of riparian vegetation. that photo on the inset sort of shows a close-up example of what this looks like. And so that can give you a very different impression of these indicators if you include the road crossing within your assessment reach. If you're trying to avoid that, usually 10 meters is sufficient. So where do you want to place your reach? There are some applications of SDAMs that don't really give you discretion. You might, for example, have a project area where somebody's proposing to do some kind of discharge or work, and you need to figure out whether or not it's a water of the US, and you're just defined by that project area. So in those cases, you will include road crossings. You might include tributaries within your assessment reach. In general, when you have atypical portions within a reach, like a road crossing or maybe a bedrock outcrop that has a bit of like a confinement in the valley, those areas that have sort of longer duration flows will have a larger influence on the classification than the areas with shorter duration flows. So basically what we're saying is that these indicators are going to be more likely to be observed if there's a small portion of your reach that has long durations, or even if most of the rest of the reach is ephemeral. The number of assessment reaches that are needed will depend again on your application. If you're talking about a small project area or a project area that is pretty uniform in terms of the channel morphology, one could be sufficient. But for larger projects, you probably need to do multiple assessments. In general, you want to place your assessment reaches to capture the differences in stream flow duration, like above or below road crossing or above and below major confluences, or in areas with different channel morphology. Can you use the SDAM in created or modified channels? The answer is yes. We do have modified channels that were included in method development. I don't think we had anything this extreme within the Western Mountains, but we do have some artificial canals that we assessed as well. So the method is developed to work in those situations. What about other types of long-term disturbances? You might have pollution or mining impacts that can really affect certain indicators like sensitive aquatic invertebrates or some of the plant distribution. The methods are somewhat robust to these types of disturbances because they do include species that are often very tolerant of disturbance. Even though many of them are sensitive, there are some tolerant species within these groups. If your disturbance will change a streamflow duration class, something like a diversion or a large discharge, the new class is likely the one that you will determine using the SDAM, particularly if sufficient time has passed since that disturbance has occurred. For more short-term disturbances, like, say, vegetation clearing, this is an example of a site undergoing restoration. I believe it's in Idaho. These can temporarily eliminate certain indicators from an assessment reach, and you won't be able to detect them if you don't have enough time to recover. Sometimes they're resilient, they'll recover really quickly, or they can actually even resist the disturbance. But it would probably be better to return and conduct the assessment several weeks after that disturbance has happened, and that gives you some impression of a better way to measure some of these indicators. When should you conduct the assessment? Ideally, the peak growing season is typically the best time because indicators are easier to observe and measure. You don't need flowing conditions. You can use the method in a dry channel. That's specifically when we intended it to be used. We don't recommend conducting an assessment in a reach that is affected by scour due to like a large rain event. Some indicators are particularly difficult to measure either because of the elevated turbidity or just because sometimes aquatic invertebrates can be suppressed by floods. We recommend a 48-hour period of waiting after major precipitation to avoid that influence. We also recommend avoiding snowy conditions. It can really disrupt the visibility of some indicators, particularly those related to the distinctness of the riparian corridor, can be hard to observe in some of these conditions.